So number 4 for problem set 1 for 3-1, copy the table, put in 3 columns, one each for the values of y naught or y hat calculated by the equation y hat is equal to 2.1x plus 3.4. The residuals calculated by the subtraction y minus y hat, the squares of the residuals, y minus y hat squared. So let us begin with the given x values. So the given x values are, this is our x, this is the given tabular data for y, and this is the table for y gotten from y hat is equal to 2.1x plus 3.4. This would be the residual, y minus y hat, and this is the square of the residuals, y minus y hat square. This is like statistics, okay? So we begin with the values of x. So the values of x are 2, 4, 6, 8, and 10. And the table gives 8, 10, 19, 18, 25. So the table gives 8, 10, 19, 18, 25. The y hat gives 7.6, 11.8, 7.6, 11.8, 16, 20.2, 16.0, 20.2, and 24.4. To compute for our y minus y hat, this is our y, this is our y hat. So just subtract. So 8 minus 7.6 is equal to 0.4. So we have 0.4 here. Okay, positive 0.4. In the second one, we have 10 minus 11.8. That is negative 1.8. Okay? And on the third row, we have 19 minus 16. That's 3.0. On the fourth row, we have 18 minus 20.2. That is negative 2.2. And on the last column, or on the last row, rather, we have 25 minus 24.4, and that will give us 0.6. Squaring this value for y minus y hat will give us 0.16, and this is negative 1.8 square. Okay, you must always put the negative inside a bracket, and then put the square at the after the closed bracket, so that will give us 3.24. And remember that if you square all of this will give us positive numbers. Okay, we have 3.0 square, so that's 9.0. Then negative 2.2 square, that gives us 4.84. And then for 0.6, that will give us 0.36. Right? So this completes the table for number 4. We have the original x values, original y values, the y hat taken from the regression line equation. Then the residuals, which is y minus y not y hat, and then the square of the residuals, which is 0. Or y minus y hat square. So this is the square of the residuals. The residuals. This is the regression line. Okay. Number 5, find the sum of the squares of the residuals. So this is number 5, and we are asked to find the sum of the squares of the residuals, and this one is this. Okay, it's abbreviated as the summation notation, Riemann sum. So this would be the sum of the residuals, and it is abbreviated also as SS residuals. So all you need to do is to add all of the residuals, the square of the residuals here. So we begin with 0.16, and then we add 3.24 plus 9.0 plus 4.84 plus 0.36, and that gives us a square of a residual which is equal to 17.6. Okay, so that is our square of the residuals, or the sum of the square of the residuals. Number 6, the regression line is the line that makes S's rest a minimum. Because S's rest is a minimum, the regression line is the best fitting line. So remember this, okay? The importance of S's rest is that if it's a minimum, so you have to compare the regression line equations that you could find by using your grapher and be able to compare it to the other two equations that are close to the fitting, okay? So for instance, for the function y2 equals 2.1x plus 3.5, notice that our y value here, or the y-intercept here, is added by a 0.4 unit. Okay, and in this case, our slope is added 0.1 unit instead of 2.1. So what is the impact of these additions to both the y-intercept, or to either of the y-intercept and to the slope? Show that SS rest would be greater for the function y2 equals 2.1x plus 3.5, and for 2.2x plus 3.4. So what we're going to do is to compare the equation, or compare all the tables that we found using this. For the function y hat is equal to 2.1x plus 3.5, and y hat is equal to 2.2x plus 3.4. So let's do that. So first, let us erase all of the given values here for the residuals and the square of the residuals. So let's erase. But we are going to retain the original values. Okay? So what if my y hat now is the function, what if my y hat is the function 3.5? What will be the result? Okay, now if my y hat is 2.1x plus 3.5, which is 0.1 unit above the regression line, y equals, our original regression line is y equals, or y hat equals 2.1x plus 3.4. So let us compute for y hat. When x is equal to 2, that will be 2.1 times 2 plus 3.5. So that gives us 7.7. This is 7.7. Then if our x is equal to 4, that gives us 11.9. If x is equal to 6, y hat gives us 16.1. What do you notice? They are 1 unit above also, okay? Right? So we have 11.8, and this one became 11.9. 16.0 became 16.1. Let's do it with 8. So that will be 20.3. And the last one will be 24.4. So what is y minus y hat here? This becomes 8 minus 7.7. This becomes 0.3. This one becomes negative 1.9. So we're going to add 0.1 unit also for this value for the residuals. So 19 minus 16.1 will give us 2.9. Or we're going to subtract rather 1.1 unit from the original y hat for the regression line here. So 18 minus 20.3, this will give us negative 2.3. And for the last one, we will have 0.5. So notice. Okay? Now what is the square of our residuals? So 7.7 minus 0.3, or that's 0.3 square, that's equal to 0.09. Right? So this is 0.09. Negative 1.9 square is this is equal to 3.61. And 2.9 square equals 8.41. And 2.3 square is equal to 5.29. And 0.5 square is 0.25. You could just take the absolute value of these numbers here and then square it. It doesn't matter because this is raised to 2. And when a negative is raised to 2, it becomes positive. So the last thing that we're going to do is to get the sum or the SS of the residuals. And in this case, we're just going to add all of the squares of the residuals. So we have 0.09 plus 3.61 plus 8.41 plus 5.29 plus 0.25, and that will give us 17.65. Now let's compare this residual to the former residual. Our former residual is 17.6, which is lower than our residual taken when y hat is 2.1x plus 3.5. Okay, therefore we satisfied the confirmation challenge for this when the y-intercept becomes 3.5 instead of 3.4. Now we're going to do another tabular comparison between y hat equals 2.1x plus 3.4 and y hat is equal to 2.2x plus 3.4. So let's do that on the next slide. So we're going to do the second part here. And remember that our original linear regression equation is y hat equals 2.1x plus 3.4. Now in this comparison, we are about to add, let's first erase all of the data here. Okay. And let us change our slope from 2.1 to 2.2. So let's erase this data. And we're going to write 2.2 instead of 2.1. So let us solve for y hat now. Let's compare here, okay? So our y hat here, when our x is equal to 2, would be 2.2 times 2 plus 3.4. That will give us 7.8. So this is 7.8. And if x is equal to 4, then that will give us 12.2. If x is equal to 6, then our y is 16.6. If x is equal to 8, then our y is 21. If x is equal to 10, then our x is equal to 25.4. Now let's get the difference or the residuals. So the residuals here are y minus y hat, this is 0.2. 10 minus 12.2, this is negative 2.2. 19 minus 16.6 is negative 2.4 or positive 2.4. Okay, we have 18 minus 21, that's negative 3.0. 25 minus 25.4, that's negative 0.4. Let's take the squares of the residuals. So 0.2 square is 0.04, right? And then negative 2.2 square, or 2.2 square, because I've taken the absolute value of negative 2.2, that is 4.84. 2.4 square is equal to 5.76. And negative 3.0 square is just 9.0. And negative 0.4 square is equal to 0.16. So now we could take our SS residual, or the sum of the squares of the residuals. So SS res is equal to, we begin from 0.04 plus 4.84 plus 5.76 plus 9.0 plus 0.16, and this will give us 99 divided by 5, or 19.8. So this is too big. Okay, now comparing this SS res to our original linear regression equation, which is this one, the linear regression equation of the original is 17.6, while the linear regression equation of the one when the y-intercept is added with 0.1 unit is 17.65, so it's 0.05 higher than the original linear regression equation square of the residuals. And then when we take our slope as 2.2, we have 19.80, which is 2 notches and 2 notches, 0.20 units away from our original SS res. So therefore, we have satisfied the conditions for number 6. So we have shown that the SS res of these functions, y hat is equal to 2.1x plus 3.5, and y hat equals 2.2x plus 3.4 are, they are indeed higher than the y hat equals 2.1x plus 3.4. Okay? Therefore, it justifies that since our chosen y hat equals 2.1 plus 3.4 has the lowest of the three SS res, then it is justifiable to be the best fitting regression line.